So tonight we'll be talking about the basics of zoning. You'll find that we'll start off with just what kind of controls you might order, and then the things to keep in mind when looking at those controls. We'll move on to just rules of thumb when doing zoning, and then last we'll kind of talk about different zoning scenarios, what to keep in mind when quoting a customer those scenarios, or what you're thinking when you're about to install one of those. And then last, we'll talk about troubleshooting the panels that we've discussed over the course of the training. So first and foremost, what is zoning? You'll find that a few of these slides are just going to be like, what is, fill in the blank. Note that the italicized bullet point is kind of your internet, Google, what you'll find there. And then the one that is not italicized, usually the second one, is going to be something that I wrote that I would just say to explain it in the most basic way possible. So basically zoning is temperature control in multiple locations of a building when only one piece of equipment is in that building, or you're only going to have one piece of equipment, but you would like temperature control in multiple rooms. When to do zoning. Basically, zoning can be applicable in any building. How beneficial it is going to vary. The biggest places where we find it beneficial is spaces that have lots and lots of windows, spaces that have buildings that have floor rooms where there's just one room that jets out and has a bunch of windows on that one room. And then your most basic application is going to be the residential multi-story home with a basement or a second story. Something to keep in mind when you're doing zoning. So on the left side here, you'll see this is kind of your typical what you're going to find in a home without zoning, and that is the basement gets cold and the upstairs gets hot. Note that when you do zone, what's going to happen is that the building or the home achieves a uniform, comfortable temperature. In this case, we're showing 71 degrees. But note that you're not going to be able to achieve 75 degrees in the basement or 65 degrees upstairs. It's going to make the entire structure a uniform, comfortable temperature. Zoning necessities. So this is kind of the 6-point checklist that we're going to start off with here. The first thing is a zoning control panel. Second thing is thermostats, on to dampers, a discharge air sensor, a transformer, and then some method of pressure control. We're going to go over each of those individually. Zoning control panel. What is it? So it's basically the brains of the zoning system. It's going to take inputs from thermostats, and it's going to output voltage to the damper and send signals to the equipment to turn on. So it's just taking all the inputs, and based on those inputs, it's determining what outputs to send out. Here are the options that we offer here at Jackson as far as standard zoning panels go. So there you'll see kind of the list. There's the ZP2HC from IO Controls. That's a 2-zone, strictly single stage with conventional equipment panel. The ZP3 HCMS panel. That is a 3-zone, multi-stage compatible, but again, strictly conventional equipment. There is the ZP3 HPS. That is a 3-zone panel that can do heat pump or dual fuel systems, but it can only do heat pump or dual fuel systems, no standard equipment there. There's the ZP6, which is a 6-zone universal panel that can be expanded up to 12 zones using expansion panels. From Honeywell, there's the HZ311. That's a single stage 3-zone panel from Honeywell. There's the HZ322, multi-stage 3-zone panel from Honeywell. And there's the HZ432. That is Honeywell's universal 4-zone panel, which can be expanded to 8 using the TAS4 panel. Things to keep in mind when you're quoting a zoning panel. The 2 pieces of information you absolutely need before you give us a call and ask for a number. We need to know the number of zones, and we need to know the equipment type. Without those 2 things, it's really difficult for anybody here to give you a good idea of what it's going to cost on the panel. Any other things that you would want to let us know, any sort of special feature requests, and then any type of pressure relief if they don't want to use a bypass damper, for example, which we'll talk about later. Thermostats. So basically in a zoning application, the number of thermostats equals the number of zones in the building. So if you have 3 zones, you're going to have 3 stats. All the thermostat is doing is it's letting the main zone panel know, hey, zone X number wants heating, cooling, or it's satisfied. And then obviously the zoning panel takes that information and makes decisions based upon that. When you're quoting thermostats for zoning, you basically still have all of the same options that you would if you were quoting them for a standard non-zoning application. That means that if the customer wants, to be able to see the temperature in the basement, the main floor, and the upstairs while they're on vacation, quote them Wi-Fi stats. They're going to be compatible with our zoning panels. If there's a zone that you can't run wire to for any given reason, quote them a wireless thermostat. We'll talk about those kinds of applications a little more later. But in general, if the thermostat utilizes standard terminal designations, RC, YWG, etc., it's going to be compatible with the panels that we're talking about. Of course, there are proprietary thermostats out there. Those thermostats are not going to be compatible with the zoning systems that we're going to discuss tonight. Again, it's mainly going to be the same as quoting thermostats in non-zoning applications. One thing that I will highly suggest is that if possible, always make the thermostat's capability match the equipment type. So if you have a heat pump, do your best to get a heat pump thermostat in that building. It just makes installation so much easier. And then another thing to note is that you're never going to absolutely need a dual fuel thermostat if there's a dual fuel system installed at the building. In zoning applications, that dual fuel logic is always done through the zone panel. Again, if you're familiar with balance points and those sorts of things, it's just much more fluid and basic if you do that through one outdoor temperature reading as opposed to 3 or 4 or however many zones you have. On to dampers. What is a zone damper? So basically, you'll see there, these red boxes are kind of pointing them out here. Zone dampers are just going to control the airflow to a given space that has a thermostat in it. So the thermostat will tell the main zone panel what it wants, heating or cooling. That panel will look at what the equipment is running, heating or cooling, and it will open or close its corresponding damper accordingly. Damper options here at Jackson. So the first and most basic that we have is going to be the D and the HD series. This is our round and rectangular 2-wire dampers respectively. So they are powered closed, spring return open. Something to keep in mind with 2-wire dampers is that they are 10 VA. They consume 10 VA of power, and they are fairly low torque when compared to the other dampers that we're going to talk about tonight. But of course, they are also the least expensive. The most popular damper I would say here at Jackson is going to be the MD series, and the RD is its retro damper counterpart. These are 3-wire dampers. They are power closed, power open, and they have 2.5 VA each and 18 inch-pounds of torque. The TD and the CD series dampers are proprietary. We'll hit those really quick in the next slide. Last but not least is the SD series. You'll see that the spec on the SD and the MD is fairly similar, but that SD has that really high torque rating. So if you need a massive damper, the person that you talk to here at Jackson is probably going to push you towards an SD series damper for that reason. Things to keep in mind when quoting dampers. The first thing is power consumption. So again, the 2-wire dampers are consuming 10 VA apiece compared to 3-wire dampers, 2.5 VA apiece. You can kind of tell just off of that. Once you get to 3 or 4 dampers, you really still have to consider the power consumption on a 2-wire damper. On a 3-wire damper, you're talking, right around 20 dampers or so before that's even really a thought. Our rule here for the panels that we sell is a maximum of 30 VA per zone. So basically, if you ever have to put more than 2 dampers on an individual zone, we automatically just say, buy the MDs. It's going to save you a lot of time and headache. And again, it just makes everything easier. The second thing is the torque. Like I had mentioned with the SD series dampers, if you have a very large damper or a very large piece of ductwork that you need to put a damper in, obviously, you're going to need a more powerful motor. The one that we sell the most is going to be the FP45, which is the actuator that we put on the SD series dampers. We can get any actuator of any spec, though, if you were to need something that required more than 45 inch-pounds of torque. Third is speed. So in certain applications, speed's going to be super vital. In others, it's not. In general, the MD series has a 60-second stroke time. We've found that that is ideal for a large majority of the applications that we're going to run into. And then we have just kind of the miscellaneous over here. So we carry the CD dampers for carrier infinity zoning systems. Those are proprietary zoning systems that you can only get from carrier dealers, but we can supply the damper for you. The same is true for the TD series. So those are compatible with Train Comfort Link systems. So we can get you the damper for a Train Comfort Link system if you need it. Another thing to note when you're quoting dampers is that you don't always have the same amount of dampers as thermostats. I run into a lot of people that kind of just assume that's going to be the case, but obviously depending on how the ductwork's laid out, you might have 2 or 3 zone dampers on a single zone. You usually will have 1 per zone, but just keep in mind that that could not be the case. You always want to use as few dampers as possible, so look at your duct layout, look it over, and think to yourself, how can I zone this and damper off every space with using the fewest amount of dampers as I possibly can. And last but not least, we can get a damper in any size with any actuator specification. You just have to call and talk to us about it. We'll get you a quote. The only thing that may happen is just a little bit longer lead time than you would on a very common size that we're going to have on the shelf. The discharge air sensor. So usually abbreviated DAS or DTS. What the discharge air sensor does is it just constantly monitors the temperature in your supply air ductwork and makes sure that it's not too hot or too cold. If it does, it will trip on high or low limit. It will purge the fan to get that extremely hot or extremely cold air out of the supply ductwork and get you back up and running once it's at a acceptable temperature. Transformer. So here are kind of the main 4 that we offer here at Jackson. We offer a huge amount, but these are the 4 that I've found the most prevalent. The TR40, so this is going to be the one that we put in the IO kits. It is 40 VA and has a 120 volt primary voltage. If you need something other than 120 volts on the primary side, you would go to the TR40 MT. So that will give you the 208 volt and the 240 volts. If you think that you might need a little bit more power for a commercial application, the TR75 will give you 75 VA. Again, you can see the primary voltages there. And if you have something that's just really extravagant, you may be inclined to look at the TR100 MT. I will point out that the TR100 is the only transformer on that list that has 277 as a primary voltage option. And again, when you're quoting the transformer, the biggest thing that you want to keep in mind is power rating. So make sure that there's enough VA there to power all of your dampers and then have a little extra for the zoning panel and the thermostats. And then the second thing is going to be the primary voltage that you require. Most of the time it's going to be 120, but you never know. It could be something off the wall. Pressure control. So the first method of pressure control is going to be a bypass damper. Again, what that is, you'll see it here. So it's just taking the air from the supply ductwork and sending it back to the return when the pressure in the supply ductwork reaches an unacceptable level. So basically, that will look at your supply pressure. If it gets high, typically above 0.35 inches of water column, 0.4 inches of water column, somewhere in there, then the bypass damper will open. We sell 2 different kinds here at Jackson. The superior one is the electronic bypass damper. What this is it's a damper assembly that has that heavy torque actuator and a static pressure sensor mounted right on it. All you would have to do is get 24 volts to it and you would be ready to go. That damper is stocked and sold in all of our typical sizes. And again, it's just objectively superior to the barometric, which we're going to talk about next. It's just going to be heavy duty, really sturdy. The barometric bypass, on the other hand, it's just a damper with a weighted arm on it. So as you can imagine, when the pressure in the duct reaches a high enough level, the weighted arm gives and opens the damper to allow that airflow to go back into the return air ductwork. Due to the nature of barometric bypass dampers, they are limited in size. I believe we stop here at 16-inch, I believe. Obviously, you kind of imagine if you get above a 16-inch round with a weighted arm on there, it gets kind of unstable, flimsy, and so that's the main reason why they stop at 16. And then again, rectangular barometric bypasses just aren't exceptionally popular, and for that reason, the stock level on rectangular barometrics are going to be really limited. You might have to go to an electronic bypass if you have an odd rectangular size. The caveat there is the price. Obviously, the barometric bypass is going to be much less expensive than the electronic, but the electronic is much more superior than the barometric. This is just kind of a brief little chart of how we suggest sizing here at Jackson. So you look at the tonnage of the equipment, and there's your corresponding damper size. In general, this is a good chart to follow with few exceptions. Things to consider when quoting a bypass. The first thing is damper orientation. So you'll see here BH stands for barometric horizontal. The barometric horizontal can only be mounted horizontally and in no other configuration. The BV stands for barometric vertical. Those can be mounted horizontally or vertically. And last but not least, the EB, the electronic bypass damper, can be mounted in any fashion, which makes, so if you need it at some weird angle, then you're kind of stuck with the EB. The second thing to recall, as I mentioned before, depending on what size you need, you may not have much of a choice in style. So we stock the EB in all configurations, while the barometrics are mostly limited to smaller rounds. In general, round bypass dampers are going to be much more common than rectangular. Tom, yeah.
Yeah, before you move on to no bypass required, we had a question come in. Could you talk a little bit about zoning wirelessly? So I think they wanted to hear a little bit about wireless thermostats, like maybe the solution from Honeywell, and even allude to maybe wireless dampers or anything that you could shed light on as far as wireless goes.
Sure.
Especially if you're doing retrofit zoning, it can be a challenge sometimes.
Right. So as far as dampers go, Jackson Systems does not currently offer a wireless damper solution. It's a fairly uncommon need. There is something called a motorized zone register, which I do not see here, but that would be kind of a workaround if you were to have a really difficult situation where a lot of the ductwork was kind of drywalled over, so to speak, and you would have to cut a lot of drywall to put in dampers. Thermostats we'll get into pretty in-depth late in this training, but there's going to be a couple scenarios where I'm going to show you later where we're talking very specific scenarios and solutions to those. Just know that for the time being, before we get to that point, if you need a wireless thermostat in a zoning application, that's definitely an option, and it's definitely achievable. Excuse me, let me go back one slide here. As far as methods of pressure control, now we're going to talk about ESP as opposed to bypass dampers. What that is, ESP stands for electronic static pressure. It's a way to zone a system without a bypass damper so that you don't have to install that green ductwork that we showed on the previous slides where it goes from the supply to the return air. So here's your kind of 6-point checklist with standard zoning, and there's your 6-point checklist with ESP zoning. So on a standard zonings application, you're going to need that bypass damper. On an ESP zoning application, the bypass damper's gone. It's replaced with an ESP panel that comes with a static pressure sensor. You'll also note that on an ESP zoning application, 3-wire dampers are required. Similarities, the thermostats, the rules for thermostat quoting remain unchanged. So ideally, you really want to have the thermostat match the equipment type, and then you can do the Wi-Fi, you can do the wireless. Again, we'll talk about that more later. Second, we highly suggest a discharge air sensor, and you're going to need a transformer for both scenarios. And then in general, they operate very similarly. The difference is that the ESP system has one additional input for that static pressure sensor. The differences. So in a standard zoning application, you have the bypass damper. We're replacing that with an ESP panel that has a static pressure sensor. So in a standard zoning, again, that bypass damper is going to open up in a return air duct back so that the excess pressure and that air goes to the return air duct system. In an ESP zoning, we have that static pressure sensor. We have it wired with 2 conductors from that static pressure sensor to the zone panel. And then we obviously have the static pressure probe put in the supply ductwork. Basically, when that static pressure probe sees that the pressure in the supply ductwork is too high, it opens the non-calling zones just enough to relieve that pressure. Usually we're talking, seconds, maybe even less, just enough so that those non-calling zones open and alleviate the excess pressure in the supply duct. Again, another large difference is the ESP systems are required to use 3-wire dampers. Ideally, the MD series dampers that we spoke of earlier. Standard wires can use 3-wire dampers, but you could also use a 2-wire damper on a standard zoning system. Again, just kind of a different way of looking at the similarities and the differences. Standard zoning, bypass damper, it can use 2-wire dampers. ESP zoning, you have the static pressure sensor that's wired in to the zone panel and opening those non-calling zones just a tiny bit to alleviate that pressure. And that system is required to use 3-wire dampers. Both of these are viable zoning options. Again, the standard zoning can use 3-wire dampers. And again, last, the thermostat should really match the equipment type on both of these. ESP panel options. So the ESP panel is made by IO Controls. So every IO Controls panel kind of just has an ESP counterpart, so to speak. The last one that you'll see there is the ESP 400. That panel is for a retrofit application. So if you had an existing zoning system that already had 3-wire dampers, but you didn't have a form of pressure control and you discovered late in the game that you needed one. This is a panel that you could install with a standard zoning panel in conjunction with it, and it would give you that static pressure ESP control where the non-calling zones open when needed to alleviate that pressure. Why do people use ESP? The biggest reason is whether the labor would just be a pain or it would be physically impossible, but they just really don't want to install this green ductwork here. It's expensive. A lot of the times, if the equipment is in a very small closet, it's impossible. That's the biggest reason why people go to this system. The second benefit is that you're not recycling extremely hot or extremely cold air into the return ductwork. Again, a bypass damper is going to take the air from the supply and dump it into the return. If it's doing that consistently enough and that air is extremely hot or extremely cold, there's potential there that it could damage the HVAC equipment. General installation considerations. So these are just this is where we're just going to start talking about kind of rules of thumb, so to speak. Again, note that every application is different. These are just our suggestions, but they might not be practical on any job site or any application. So the first thing is just tag everything if you can. Tag your wires to make it impossible to miswire the thermostats or the dampers. We also like it if you were to tag the zone panel. as to what piece of equipment it's going to. You know, on these commercial applications, you might have 4 rooftop units. If you do, on the zone panel, right on the zone panel, just slap RTU1 on the first zone panel that's controlling RTU1. And then if the building owner, whether that's a homeowner or more likely a commercial building owner, allows you to, it's great if you can put on a thermostat unit 3, zone 2. You know, it just makes troubleshooting later on and even installation from the get-go a whole lot easier to follow so that you aren't double guessing yourself. Zone damper installation. So you always want to install the zone dampers so that they can be accessed later on. Again, I mentioned you don't want to put them in a place where they're going to be drywalled over later. If it ever needs to be replaced or you ever need to do troubleshooting, it's just it's a huge benefit to put them in a space where you can get to them later on in the game. And then we always want them to be 10 feet from grills or zone registers if possible. Basically, mostly that's a noise thing where we don't want the homeowner or the building owner to hear whistling or motor noise if we can help it. Another just rule of thumb is basically usually you can run 300 feet to any thermostat or any damper without concern. Just know that if it's 300 feet or less, it's not going to be a concern that there's a drop off in current or anything like that. Always use a separate transformer when installing a zoning system. Never, never, never try to use the transformer from the equipment. I don't care how large it is. It's just another thing that could go wrong. It just eliminates one more thing, and obviously installing a separate transformer is not a huge cost. It's just good practice. Isolation relays may be needed. So this is a situation where if you have a bunch of 2-wire dampers installed on a single zone and it's exceeding that 30 VA max that we talked about before, you may need to install isolation relays so that you don't zap the board and it can't give it a power load that it can't handle. Again, isolation relays can get really messy. Installing them can get really convoluted and confusing. An easy way to avoid doing that is just to use a 3-wire damper. Again, the VA consumption is just so much less. It's just going to be a relief of a headache. Depending on what the request is, what the budget is, etc., which products that you're going to use is going to vary a lot. I think there's going to be 4 scenarios here where we're just going to kind of talk about how the request altered what we chose to quote. And a couple of them we'll even talk about how what we just chose to quote kind of comes together from a control standpoint. So here's just our first scenario. So the customer has a 3-story house with 2 heat, 2 cool conventional equipment installed. They want Wi-Fi stats in every zone. And last, they have an odd ductwork layout that they need 5 zone dampers in their basement in order to properly control the airflow in the basement. So the first thing, it's 3-story home. We're going to look at a 3-zone panel more than likely, and it needs to be compatible with a 2 heat, 2 cool conventional piece of equipment. So that's going to heavily influence what zone panel we're going to look at. Obviously, the Wi-Fi thermostat request is going to input what thermostat we choose. And then the damper quantity there, it's going to make an influence on which damper we might choose. So for the zone panel, we're going to suggest the ZP3H CMS. That is the 3-zone, 2 heat, 2 cool panel from IO Controls. That gives us the 3 zones and it gives us the equipment compatibility. Easy. Thermostats, you can choose any Wi-Fi stat You know, a lot of homeowners like Ecobee, we carry Nest, we carry the Honeywell Wi-Fi stats, but you'll just want to choose a Wi-Fi stat, converse it with the homeowner. Obviously choose one that you're comfortable with, that you're familiar with. Dampers, we're going to say the MD dampers are going to be the best for that scenario. Again, the MD is our most sold 3-wire damper. Because of that 2.5 VA consumption, it just makes it, you can install those 5 dampers in the basement without a worry. Excuse me. Do we have something, Tom?
Yeah, go ahead.
We're on the next scenario. So
Okay, yeah. They are sending in questions at the speed of light, and I've been trying to answer them, but I give up. So we're going to try to address some of them here live. Okay, so there was a couple questions about the ESP, and they wanted to know, and you may have covered it. I was so busy and engrossed in questions about adjusting the static pressure set point.
I didn't cover it.
Okay.
So on the ESP zoning panels, they all ship, if it has ESP in the part number, it ships with the static pressure sensor. That static pressure sensor just has a translucent cover on it. You would pop that translucent cover off. There's a dial there that you can set that static pressure anywhere from 0.08 inches of water column up to 1.2 inches of water column. So you have pretty much anywhere that you could dream that you want that to trip at. We ship it at 0.35 inches of water column, I believe, but that is a huge benefit to that system, is just how easy it is to adjust at what static pressure you want that to start opening the non-calling zones. Is there anything else, Tom?
Yep, there's a bunch here.
Okay.
See if we'll. Someone asked about a dump zone. This is going back to bypass dampers, and they said, well, what about, could you use a dump zone? Which, of course, that used to be the more common method, is pick a part of the house that you, instead of bypassing it, you dump the excess air into an area of the home.
Right.
And while that does work great, I think you would agree, Ty, that the thing that we always say, well, what part of the house don't you want to be very comfortable?
Right.
I mean, if they had a room that never got used for whatever reason, that would be okay. But I would really prefer the bypass, because then if you put the proper safeties on there with the
well, you prefer the bypass, and then another thing is, if you just say that you can't do a bypass damper, and so you're just going to do the dump zone, and that's why. The ESP panel, it's just kind of better practice, in our opinion, to kind of share that excess pressure airflow to the non-calling zones. And another beautiful thing about the ESP that we're going to talk about in one of these scenarios, actually, is that you can turn off and on the ESP function on a per zone basis. So if you're saying, you know, I want to choose a dump zone because I don't ever want airflow to leak into the master bedroom at any time, well, that's perfectly acceptable. You would just do an ESP panel and put zone number 2, let's say, as the master bedroom, and have the ESP feature off just on that one zone, so zone 2 never leaks air.
Yeah, so I think that was another question worded a little differently. They said, is there a limit to which ESP zone panel is allowed the non-calling zone to overshoot? So yes, you can turn the ESP function on and off by zone.
Yep.
So that's
across all the ESP panels. That's true.
Yep. And then someone asked, I'm not sure, I must have missed the slide there, honestly. I got caught up in questions, said, how is an isolation, I'm assuming relay, wired up?
So an isolation relay, again, this is only in a scenario if you have a large amount of 2-wire dampers. And I personally highly suggest that you just install 3-wire dampers. But an isolation relay, when it's installed, what you would do is you would take your damper output on the zone panel and wire that to the coil of the relay, so that that relay gets energized when that damper sends out voltage. And basically what you would do, you would have to have a separate transformer for that particular zone that you're using an isolation relay on. And you would wire the transformer to the common of the relay and wire the dampers to the normally open contact of that relay. So basically that transformer is powering the zones that you have, the dampers that you have on that relay when the zone panel is sending out voltage for that zone to open.
All right, and then someone asked, about, they said, can we use Wi-Fi thermostats that don't have a common? So
The answer is no. The reason for that is that the zone panels just simply do not respond to non-battery powered thermostats without common the components on it tend to struggle to accept those inputs because it's not seeing the true 24 to 27 volts that it wants to see. Those power stealing stats.
Well, what about a battery-powered, like the Sensi and Brayburn both have one that is a battery-powered Wi-Fi thermostat? Would that work okay? I think it would.
So, yeah, that one would. I believe, if I'm not mistaken, that's only compatible with conventional equipment.
I believe so, yeah.
But yes.
But power stealing, definitely a no-no,
Yeah,
but you don't see a whole lot of power stealing
stats. If it's
stats.
not utilizing a common wire because it's power stealing, you could not use it. If it is battery powered and it just doesn't have a common, you could. That said, very few Wi-Fi stats are battery powered because the Wi-Fi capability requires a high power consumption and you would just be changing batteries a lot.
Yeah, but you can do an add-a-wire or something
Yes,
probably too.
yeah, and
there are some options.
Right, and Echo Bees I know for sure. I'm sure there's a few others. Some of them just ship with the add-a-wire in the box. So it shouldn't be a production to add that common wire.
Okay, I think we're covered. There's someone giving my brother a hard time, so that's good. Appreciate that. But anyway, I think you're free to move on.
Okay.
If I miss someone's question, please send it again because we got so many questions all at once.
Right.
It was a little daunting there.
All right, so here's a scenario B that we'll just briefly talk about here. So you're quoting a light commercial zoning system that requires 9 zones. And due to the large quantity of zones, it has been either your choice as a contractor or a customer-specific request. But you don't want the equipment to upstage unless multiple zones are calling. So capacity, what we call that capacity control. So the capacity control feature is desired here. So first and foremost, the 9-zone system is obviously going to influence what zone panel we choose. Also potentially thermostats and dampers. Obviously, if we have a lot of zones, we have a lot of thermostats and dampers. The quantity there may have an influence on what on what thermostat or damper we choose to install. The second one is another zone panel request. Basically, it's asking for a very specific special feature that they want their zone panel to be capable of. So what we would quote here, the ZP6 with an expansion panel. So the ZP6 does 6 zones by itself. You add an expansion panel, you get 9. You add another expansion panel, you get 12, just as a side note. But that will give you the 9 zones. And that ZP6 panel is also equipped with that capacity control feature. It's a very popular feature. It's just a little set of dip switches that you say, hey, 2 zones, 3 zones, 4 zones, whatever you wish. This many zones must be calling before this board is allowed to upstage to second stage heating or cooling. So that would cover you on that as well. Dampers, we'd suggest MD or SD again. The low power consumption, since you're installing at least 9 here basically. And then additionally, in a commercial application, 3-wire dampers are just kind of a more robust solution. And so in commercial, it just kind of makes sense. That kind of falls through again on the bypass damper choice with the EB damper. Again, more robust. In a commercial setting, that's just more common. And then last, thermostats. Again, it's just a really popular commercial thermostat we sell. You could install any thermostat, but the Vision Pro is just a really popular stat that would be suitable for this scenario. Scenario C. So they want a 4-zone system, and it's going to be on a heat pump. Running the thermostat wire, the wire running to the current system did not account for the heat pump upgrade. So new wire getting to those zone thermostats would just be super difficult or just impractical, or maybe it's impossible. Regardless, you're choosing wireless thermostats to be the best solution, and you need a wireless thermostat in all 4 zones. And last but not least, the end user, the homeowner, whether it's a homeowner or a small commercial building, they want internet access on these thermostats. So obviously, the internet access and the thermostats being required as wireless, that's going to dictate what thermostats we're looking at. And the 4-zone system with heat pump compatibility is going to dictate the zone panel that we're looking at. So the zone panel that we would probably quote here is the HC432 from Honeywell. This is a 4-zone system, and it can control a heat pump, so we're set. The reason why we're choosing this one specifically is that it's compatible with the wireless zoning adapter, which the part number is listed there. What that wireless zoning adapter does is it is just one component, and it allows all 4 thermostats to be wireless, as opposed to all 4 thermostats having their own equipment interface module. This is just one thing that allows all 4 thermostats to not run any wires to the zone panel. Because of that, though, there's not just any thermostat that's compatible with this stuff. So we're going to choose a RedLink Vision Pro for that reason. Again, no wire will be needed to go between the thermostat and the zone panel. And then we're going to quote them a RedLink Internet Gateway. Basically, this is a way to give RedLink thermostats internet access, and it's one of the few, if not the only way, really, to give a customer who requires wireless thermostats internet access to those wireless thermostats. Here's kind of what that looks like. So again, there's the HZ432 panel. It's just 4 wires from the wireless zoning adapter to the panel that you'll see there. That panel's getting RedLink signals from both the thermostats and this gateway here. This gateway just has an Ethernet cable that plugs right into your router. So it's getting that internet communication hardwired through that Ethernet cable. It's taking that information from the router and it's projecting it out on a RedLink signal back to that wireless zoning adapter. Again, there's no wires going from the wireless zoning adapter to the gateway or the thermostats in this scenario. Yep.
2 things. First off, Rachel, your boss, is watching and says you're doing a great job.
Oh, great.
So, I've had a couple of questions about zone, I'm going to call it zone disparity. So they want to know what happens if you've got one really large zone and one really small zone. So maybe like you've got the entire house is on one zone except for you got the bonus room above the garage that's only, 15% of the total system CFM. Do you have any recommendations? I mentioned to the one gentleman that you may have to set a minimum position on the large zone damper so that even when the large zone's not calling, you still get some airflow through on the large zone. But
so it kind of depends. So you're right about the minimum position. That could be a scenario where you need that. Depending on the exact application, obviously every zoning application is going to be different. But if it's a situation where it is a bonus room or a Florida room or something kind of odd like that, where you don't necessarily need that zone to dictate what the equipment's ever doing, we do have a system called a Zone 1. So you would just leave the rest of the home standard with just the thermostat controlling the equipment. But in this extra room that we're talking about, it would be a thermostat wired directly to a damper. And all that thermostat would be doing is saying, hey, I want heating or cooling. I have a duct temperature connected to me. I can tell what the temperature in the duct is. Is it hot air or is it cold air? And based on that information, it tells the damper, close or open. So I want heating, but the air is cold, close the damper. Vice versa, obviously still close, but if they agree with one another to say that they want cooling and the temperature in the duct is cold, then it knows to open. So that's kind of an indirect way to control the airflow or the temperature of that bonus room, so to speak, or that smaller zone. And then you would just give the much larger zone actual control of what the equipment's doing. Anything else, Tom?
Yeah, but keep going. 'Cause
Okay.
there's a lot of questions here.
So this is the last scenario, I believe, the scenario D. So it's a 3-zone system on a dual fuel piece of equipment. There's no room to install a bypass damper in this application, but they never want zone 2, the master bedroom, to bypass air to relieve the pressure. And then last, one of the 3 zones needs to be wireless. They cannot run wires to that 3rd zone, so it needs to be wireless. So obviously the first 2, both the dual fuel kind of system and the 3-zone, that's going to determine the zone panel. And then also, they don't want to install a bypass damper, is going to also obviously kind of impact what we're going to quote them, if you can't see that ESP zone panel quote coming. Last, one of the thermostats needs to be wireless. That's going to at least influence what we quote on one of the zones, as far as thermostats goes. Here's what we would do. Here's what we would suggest at Jackson anyways. It would be the ZP3 HPS ESP zone panel. So that's a heat pump zone panel with ESP control. What you would do is move the zone bypass. That's what it's labeled on the panel. But you would move the zone bypass jumper on zone 2 to the off position so that that zone 2 does not leaks air to relieve the static pressure in the duct system. And then another thing to keep in mind is the outdoor temperature sensor for that panel is the ZPA OTS. Again, if this is a dual fuel application, you or your customer may want balance point control. So, lock out the compressor at an extremely low outdoor temperature kind of situation. Thermostats, we're going to go Honeywell RedLink again. Obviously, we do have other wireless thermostats, but RedLink tends to be people's favorite. You'll need one equipment interface module in this scenario, and we're going to go 3 of the RedLink Vision Pros just so that all 3 zones match. They don't have to match, but that's why we're quoting 3 of those. And here's what it looks like. So this is your one wireless thermostat communicating to this EIM. The EIM you would just wire into the zoning panel thermostat terminal as if it were the equipment. Nothing fancy there. And then you have 2 standard Vision Pro thermostats that you would just wire directly into those terminals. Right here is a little box. That's where the jumper's located, basically adjacent to the hot and common of each zone thermostat terminal. So on zone 2, you'd make sure that jumper was in the off position. And then if you were so inclined to include an outdoor temperature sensor, it just wires right on down there. These dials are for your high and low balance point temperature settings. Now we're going to talk about a little bit of troubleshooting. In this example, we're going to talk about the ZP3 HPS across almost all of the panels. The troubleshooting steps or things to keep in mind are going to be the same. There's small differences, and I'll try to make sure I bring up those small differences in ESP panel situations and that kind of thing. Here's just kind of a list of the features of the ZP3 HPS specifically. Nothing fancy there. That's just what it comes with there. So first things first, just kind of making sure you're familiar with the panel here. So you have zone 1 thermostat, zone 1 damper, zone 2 thermostat, zone 2 damper there. Down here is where you wire in your transformer for your power to the system. Your HVAC equipment would come in right here. Note that the common's not wired. None of the zone panels that we talked about today is there going to be a common wire from the equipment going to the zone panel. They are dry contacts. Discharge air sensor there. LED indication. So you got your 24-volt LED that just tells you power is on. These are your equipment call LEDs, so if the LED is on, it should be getting outputted to the equipment. The limit LED is just on when a discharge air sensor is connected. It flashes if it trips on high or low limit. And then the zone damper LEDs, those are on anytime the zone damper is open. One quick note I want to make there is that they are on anytime the zone damper is open. That is not to say that they are on anytime the zone damper's corresponding thermostat is calling. So if no zones are calling, the LED will be on. And then obviously the zone thermostat could be calling, but the HVAC equipment could be running the opposite mode. So the thermostat could be calling for heating while the equipment's running cooling because a different zone is calling for cooling. So just note, I get a lot of calls from time to time saying zone 1's calling but its damper's not open. I look at the zone panel, zone 1 LED isn't on, and so it knows zone 1 damper isn't open, and there's a reason for that. So here we go. Kind of made it white to make it a little easier just to visualize there. But basically what you want to do when you're quoting zoning systems is you want to isolate the different things wired or connected to the panel. So that includes the thermostats, the dampers, the panel itself, and then last, the equipment. Big thing that's really troubling from time to time is just make sure you're not making assumptions. You know, it's very frustrating for everyone if you call it in from the get-go and it was just a simple wiring mistake that took you half an hour to communicate via phone to really discover. And then last, understand the sequence of operation of the panel. All of the installation manuals for the panels that we've talked about tonight are on our website. So if you're in a situation where the manual's not there on site, which obviously is the case a large majority of the time, go online, find the manual, make sure that you really understand what's supposed to be happening, and then go from there. As a note, the fuse down here is protecting your transformer and all your thermostat terminals. The fuse down here is protecting your HVAC system terminals. So obviously, if you're saying, I'm not getting output voltage to my thermostat and my thermostat's not on, or I'm just not getting power to my zoning panel, or you're saying, I'm not getting outputs to my HVAC equipment, check the fuses first and foremost. Make sure it's not just something really, a really low-hanging fruit kind of issue, so to speak. So again, isolation's key here. So what you'll do is you'll check your zone thermostat terminals for voltage first and foremost. So you're saying, I'm looking at zone 2 thermostat in person right now, and it is calling for cooling. Get a multimeter out, check AC voltage between common and Y1. Make sure that there's 24, 26, 27, whatever it may be, volts there. If there's not, and you can see that the thermostat is calling for cooling right now, then it's probably either a problem with the thermostat where the relay of the thermostat is not latching properly, or it's a wiring thing. It could be a wiring mistake, or it could be a damaged wire. But simply said, if you can look at that thermostat and with 100% confidence saying, this thermostat thinks it's calling for cooling, and you can go to the zone panel and you can see that that zone panel is not seeing 24 volts between common and Y on its corresponding thermostat terminals, the thermostat never saw the call. So it can't do anything with it if it hasn't seen it yet. That means that it is in fact a problem with either the thermostat or the wiring. And the wires could be damaged or it could be miswired. If you see voltage there, the next thing to do would be go to its corresponding damper. Again, if this LED is on, we should have 24 volts on the power open terminal. So you would read 24, take a multimeter, read AC voltage between common and power open, and hopefully you would see 27-ish volts there. If you say this damper LED is on and I don't see voltage coming out of there, then it's a panel issue. Something that is extremely important, that is it's non-intuitive, so I understand people not knowing that this is what you have to do. But when you're reading damper outputs on a standard zoning panel, you must disconnect the damper wires from the damper actuator. This panel will only read 100% accurately without a doubt if that load from the damper has been removed from them. And then oppositely, ESP panels are the exact opposite. So if you have an ESP panel, the wires from the dampers must stay connected in order to read an accurate voltage reading. The reasoning for that, just for some background, is that standard panels use relays to shoot out voltage out of these outputs. so you have to remove the wires to get a good reading. ESP panels use triacs for those damper outputs. Triacs depend on a load before they read accurate voltage. So you need to leave those dampers connected on an ESP panel only. But again, here we have a standard panel. You remove the damper wires, you put the multimeter there. You see there's 27 volts, great. If there is not 27 volts there and that LED is on, then it's a bad panel. Again, if the LED is off, you should be 27 volts between common and power closed. It's that easy. And then from there, you want to check the equipment. You're saying, you know, my zone panel's saying Y1 cooling's calling, but my air conditioner is not turned on. Again, another vital thing here is that you want to disconnect your R wire from the HVAC equipment in order to get an accurate reading here. But again, these are dry contacts. So when you're taking readings at the HVAC unit side, you want to change your multimeter setting to continuity. It's often shared with the resistance setting on a multimeter. And you'll disconnect your R wire from the equipment. Again, that's very important. And you'll put the multimeter leads to R, and in this example, Y1. If you have tone, then that means that without a doubt, this panel is sending a signal to the equipment for cooling to turn on. And if the equipment is not turning on cooling, again, it's either an equipment board problem or it is a wiring issue, whether the wire could be damaged or it could be miswired. If you don't get tone out of this and you can say, the Y1 LED is on, I have disconnected my R, I have put my multimeter on continuity, and I have put my leads across R and Y1 and I do not have tone, then it is a board issue. Something to note is it's really easy, especially if you have an unused zone like we do in this situation. It's really, really easy to test this without relying on thermostat signals. Obviously, we all know they have time delays and that kind of thing. You can just use jumper wires on the non-used zone, in this case zone 3. And you can say, okay, R to Y1, just jumper it at the thermostat side, make sure that the LEDs correspond with it, and then read it like that. That way you can say without a doubt, you know a zone is calling for cooling. And you can do it with heating or fan or whatever you want, obviously.
Okay, bunch of questions.
Okay.
The first one, he wanted to talk about priority on the panels, which is a great question. Is
Okay.
it cooling priority, heating priority, first call priority?
So it's not consistent across all the panels that we've talked about. I can say without a doubt that the standard 2 and 3 zone panels from IO are first call priority.
And you may want to explain what priority means too, because I
Sure.
think that's probably something that
Sure.
is not common.
So priority
terminology.
just means that if a zone panel receives contradicting calls and that any given zone is calling for cooling at the same time as another one's calling for heating, what does the panel do about that? So from IO, all 2 and 3 zone panels, whether they're ESP or standard panels, are first call priority. That means if the heating call came first, heating wins. If the cooling call came first, cooling wins. The 6 zone panels, again, both the standard and the ESP version, they have an option. You can either choose cooling priority, which obviously would kind of mean if one zone's calling for cooling and 3 are calling for heating, it would still output cooling because you chose cooling priority. Or you can choose majority wins, which is the much more popular choice. And that would just mean in that same scenario, 3 for heating, 1 for cooling. Heating would win because 3 versus 1, majority wins.
All right, next question. And this can be, we can talk lots of different ways about this, but he says, are the 3-wire motors compatible with the Honeywell ARD damper as a replacement motor so that you don't have to remove the entire damper? So if they had a Honeywell ARD, can you take off the Honeywell motor and put one of our one of the IO which is a BLEMO motor on there.
So I believe the answer is yes, but the answer I can be 100% certain of is that if the damper itself has a shaft of a 1/2 inch width or 5/8 inch width, then the BLEMO actuator will fit on it.
Yeah.
If it is smaller than that, it probably will not.
Yeah, we make we have a bunch of different shaft adapters
Right.
available. So if you have a scenario, probably just call in and let us just double verify.
Right. I would say basically if you're looking to replace a damper actuator with something that's not the exact replacement, when you call in, know the size of the damper shaft, and we'll be able to get you the actuator you want with the shaft adapter if needed that you might need.
And then I think you talked about this in one way. He's talking about do we need to disconnect the wires from the zone damper to get a reading for powered close as well?
Yes. So on standard panels,
I need to repeat that question just so.
So if the question was on powered closed, do you also need to remove the wires from the damper in order to read it accurately? The answer is yes. On standard panels, whether you're reading it from power open or powered closed, it doesn't matter. In order to get an accurate reading out of those damper terminals, you must remove the actuator wires.
Okay. Another question along that same scenario. You test continuity between R and Y with the 24-volt power on.
Yes.
Yeah.
Yes. Because simply put, without 24-volt power, these LEDs don't work. So you're only going to hear tone when its corresponding LED is on. So yes, you would leave the power on the board. You can turn off the power for the equipment transformer. It doesn't make a difference, but yeah.
They asked about, says, could you explain the phasing procedure needed to set the control panel and the HVAC equipment transformers up properly? And I don't think you really need to phase the transformers. You're going to use two separate transformers.
Right.
They're electrically isolated, so you don't have to phase the transformers.
Yeah. And Tom explained it perfectly. They're electrically isolated because these are dry contacts. The two transformers do not need to be in phase. So you don't have to take that into account with anything we've discussed today.
Yeah, I don't know, last time, early on, and when we first started back in the 90s, there was some talk of phasing transformers, but we never run up against it anymore, so I think you should be in good shape there. How large zoning dampers are available, and can this system work in commercial applications?
Yeah, I mean, obviously the ZP6 and the HZ4 are kind of the larger panels that are going to have more advanced features that you might desire in commercial applications. But any of the panels can be used in commercial applications.
Sure.
As far as damper, I mean, I know I've quoted one that was 108 inches by 60 inches. You know, we can get astronomically huge.
We stock up to 18-inch round and...
We stock up to 20-inch round.
20-inch round.
And we stock up to something like 30 by 20 rectangular.
Yeah, but we can get any size.
Yeah.
We can have any size made. So
Right.
So that takes care of about 99% of the applications that we have in stock. So I'm sure I've missed a bunch of questions.
We're close to done. So
Okay.
if you have, I think I might have one more, but maybe not. Let's check, I guess. No, that's it. So.
Yeah.
So we're just on questions.
Yep.
If your question didn't get answered, if you want to repeat it in the chat, feel free.
Yeah, because I see a lot of unanswered status on my board here. I'll never be asked.
You want to go up and I can.
Okay. I'll probably never be asked to come back to a training because I did absolutely horrible. Good evening, everyone. I'm the gentleman that's been trying to answer your questions feverishly. I apologize for my inability to type and listen and all that. So we turned Tyler over to the computer to ask any more questions anybody's got. I think, was this your first training?
It was.
Yeah. So congratulations to Ty. He did an awesome job. Tons of information to try to get out in a very short period of time. So we really appreciate everyone showing up this evening. and we'll continue to do these trainings. We've got a lot of cool things in the works with technical stuff, especially as it relates to zoning. So we look forward to having everybody back. Any more questions come in, Tyler?
We're still waiting on a few. We need to go a little bit longer for NATE certification.
Oh,
So we need to make sure we hit the time limit because it is
yeah.
2 credits.
Yep. And again, I don't know, did you spend a lot of time talking about discharge air sensor?
Not particularly. I
Yeah.
mean, I hit it quick.
Okay. Yeah, that's something that always comes up with I know when I'm doing a in-person training, the technical people always want to hear a little bit more about the discharge air sensor. The panel, all of our panels, we highly recommend that you always use a discharge air temperature sensor with it. What about adjusting the discharge air temperature? I know that always comes up in the training.
So again, that varies by panel. The ZP6 and the ZP6 ESP, you can make the high and low limit temperatures whatever you desire. On the smaller 2 and 3 zone panels, you can adjust the high limit temperature between 130 and 160 degrees. The low limit is fixed at 45 degrees.
Okay.
But again, as Tom said, it's always highly suggested. I know a lot of people try to save the $15 or whatever it is, but it's definitely just a better safe than sorry scenario.
Well, and I know this is this is actually a fresh air ventilation controller here, but it's the same on all of the IO zone panels as well. If you open up the enclosure and you look inside, there's a label in there, and that'll give you a lot of the data that you need as far as the temperatures and so forth and the terminal designations. So if you ever have questions, definitely flip open the panel cover and take a look in there. And of course, you can always call us, and we'll answer the phone and
Right.
and walk you right through anything that you might need.
A couple things I wanted to point out, I guess, because I talked about a lot about the thermostat matching the equipment capability tonight. Consider the zone panel features when you're looking at what thermostats you might want to quote. A couple notes is, first and foremost, the ZP6 and the ZP6 ESP come equipped with a staging timer. So if you're stuck in a scenario where the zone thermostats are single stage thermostats, you only have 5 conductor or whatever it may be going to your zone stats, so you're kind of stuck with the single stage thermostats, but you upgraded the equipment to multi-stage equipment, let's say. You can use the ZP6 stage timer to send second stage outputs while only having single stage thermostats installed on the job.
Yeah.
Another thing that I will praise the Honeywell HZ432, that panel might be the only one we offer here at Jackson that can take conventional thermostat calls and use those conventional thermostats to control a heat pump equipment. So if you're stuck in a scenario like that, that panel could get you out of that kind of bind.
Yeah. The other thing I was going to bring up, anytime you're doing zoning, now I know if you're doing retrofit zoning and the homeowner or the building owner is just adding zoning and they're not doing equipment replacement, then you don't have a lot of option. But if you are doing equipment replacing and you think zoning is going to be part of that, always, if you can, use 2-stage equipment. It makes it a much better job, because if you only have one zone calling, then let's only bring on first stage. So anytime you can use multi-stage equipment, that's a real perk. And then the IO 6-zone panel, the regular one, I don't think the ESP does it. You can actually set the number of zones that have to be calling before it'll even allow the equipment to upstage.
They both have that capability,
they both have that,
actually.
okay.
But yeah.
Somebody ought to teach me something.
We briefly mentioned
can I get Nate credit tonight for this?
We mentioned that capacity control feature under one of the scenarios, but exactly. So if you have a large amount of zones, some of which are very small, maybe if zone 1 is just a small office and it's been calling for 20 minutes, and normally that would cause the equipment to upstage, maybe in that scenario you don't want the equipment to upstage just because this one zone is calling for cooling for 20 minutes. So that capacity control feature is pretty nice with that.
Yeah, cool. I was going to have, did you cover fuses?
I did,
Okay.
briefly.
All right.
Yeah.
I know that always is a popular question. And what about, I know I heard you talk about dual fuel
Yep.
a little bit. Anything special with dual fuel, whether it be ours or Honeywell's or any?
Just to keep in mind that both panels, IO or Honeywell, they want the dual fuel logic to be done through the zone panel. Again, the reasoning for that is just if you have 4, 3, 4, however many outdoor temperature sensors that all are reading a little differently, or the balance points are set a little differently, and they're all determining what kind of logic they want to run just a little different from one another, things can get kind of clunky. It can be really hard to troubleshoot. But if you have one outdoor temperature sensor connected to the zone panel and all of that logic is done at one place, it just makes it so much more streamlined and easy.
So what about the thermostats? You set them up as dual fuel thermostats or as heat pump thermostats?
Good question. So they're always configured for heat pump thermostats with a conventional standard electric backup heat. You would never configure them for dual fuel. You'd tell the zone panel that it is controlling a dual fuel system. That way it also knows to never output a compressor call with a backup heat call and that kind of thing too.
So like on this panel, if you were doing dual fuel, you would set up the thermostats as a normal heat pump thermostat, not dual fuel, just regular normal heat pump. And then on this particular panel, there's a little switch right up here at the top that says conventional or fossil. So you would throw that if you're doing the dual fuel.
Right.
And then you'd want to make sure you got the outdoor thermostat as well.
Right.
So anyway, any other questions come in?
Oh, we got lots of questions.
Oh, well, what are we up here rambling about then?
All right, so we've had a few people that want to kind of revisit the large zone, small zone scenario,
Okay.
and maybe talk a little bit more about the zone 1 option that you guys talked
Okay.
about. a while
Sure.
back.
Yeah.
So a zone 1, the more
This is a particular product. Zone 1 is the name of the product, right?
Zone 1 is the name of a product. There's 2 options. There's a modulating one and a 2-position one. The modulating one is quite a bit more popular, to be honest. What it is it's a thermostat, and it's wired to a zone damper. That zone damper is going to have a tiny printed circuit board on it. That's where the thermostat will wire into, right into that circuit board. That circuit board also has the damper actuator wired to it, and it has some form of a duct temperature sensor wired to it. So basically that little actuator board in conjunction with the thermostat is looking at what the damper is calling for, whether it's heating or cooling or it's satisfied. And it's looking at what the duct temperature is, whether the air is hot or cold. Usually, I believe both of these 2 products, whether it's 2-position or modulating, they're going to determine 72 degrees as kind of the give point. So if it's below 72, it's saying that's cold air. And if it's above 72, that's hot air. But it'll see if it's cold air or hot air. And based on those 2 pieces of information, what it sees is the duct temperature reading and what it sees the thermostat calling for, it's going to open or close that zone damper that it's connected to.
Yeah, but it does not connect. There's no zone panel,
No.
and it does not wire back to the equipment or anything. It's
So
completely standalone.
in that
the
scenario-
thermostat wires directly up to the zone 1 damper that's got the little printed circuit board on it, and that's
Right. It's important to note that in that scenario, that the design purpose for it is to prevent overheating or overcooling. What it will not achieve is that zone thermostat will not have the ability to turn on or off the equipment. There is a separate thermostat somewhere in the structure controlling what the equipment is running. And this thermostat is simply opening and closing a zone damper based on what the equipment's running, basically.
Yeah. So that's definitely a great scenario for those if you've got the big disparity between zone sizes. I know I think several people were asking that, and I was try to answer that. If you've got, sometimes you have no choice. But if you had one zone that was 95% of the total system CFM and one zone that's 5%, that's not a really good layout of a system. I mean, sometimes you just may not have an option. It may even be that if it's too dramatic, you may have to consider something like a mini split or something, because at that point it gets really tough. But the basic premise is if you had real big disparity, the big zone, you're probably going to have to set a minimum position on that damper so that when the tiny zone's calling, you're going to get a lot of air leakage into the non-calling zone. because you need a minimum amount of CFM over the coil and all those things. You got to make sure that you've got your discharge air sensor in place, and you're going to have to, if you're doing traditional bypass, you're going to have to size your bypass pretty large, because it's possible it's going to handle a big chunk of that total system CFM, which is, ideally it's not what we would like.
Right.
But if that's your only choice, I think Ty's solution with the Zone 1 is actually probably the best scenario. It's going to be a lot better than having nothing at all.
Right.
You're not going to freeze them out or burn them up. But if you have to do traditional zoning, then we're going to have to look at setting minimum position on the big zone damper.
Yeah.
All right. So next question is from Dwayne. You'll have to make sure you repeat the question since I'm not mic'd.
Gotcha.
Oh, sorry.
Dwayne asks, do you recommend supply and return air on the same zone?
Say that again.
Maybe if you can ask, does he mean dampering, having dampers on both the supply air and the return air on every zone? Maybe that's what he's asking.
Yeah.
So Dwayne, you can have him try to reiterate.
So
Yeah.
I'll just answer it as if it was, and he can correct me if he needs to. But he asked, do we recommend having a damper on both the supply air and the return air on every zone? So if you do, great. It's going to give you even better comfort and control. But it's really expensive to damper off every return air duct. And I personally, I don't think it gives you enough additional comfort to.
I've heard of one person ever doing that,
Yeah.
and you can all guess who it is. It was my father. And about 3 houses ago, he determined that they were hardly ever going to use the upstairs, so he didn't want to pull any air from upstairs on the return. So not only did he put in a supply damper, he installed a return air damper, and that is literally the only time I've ever heard of anyone putting in return air dampers. As Ty alluded to, it's in a perfect world where there was limited amounts of cash, like it was the federal government, then doing both the supply and return would be awesome, but no one does it.
Yeah.
Put the money in your pocket, because you're going to get almost as good a temperature control.
Yeah.
So.
So this question is from G. Nathan. Does the I/O panel offer anything like the Red Link for wireless outdoor sensors?
No.
It does not. No.
We do not have, the I/O does not have a wireless outdoor sensor like the Honeywell. Honeywell has done a really nice job with the Red Link product, and we're obviously huge wholesalers of Honeywell. We sell a tremendous amount of Honeywell zoning and thermostats, and their Red Link is world class.
Yeah.
So
if you're stuck and you just think that you absolutely need a wireless sensor, that would be another reason to go the Red Link route. But I/O does not offer an equal.
Yeah.
Harold asks, does the control work with oil or gas?
Either one.
So again,
Oh, sorry. Someone asked, Harold asked, does it work with gas and oil? Sure. Yeah. There's short of some temperature differences, output temperature differences. There's really nothing different about how it works.
Logic-wise, it's all the same.
So both gas and oil would work.
Yep.
Okay. Next question is from Manuel. He says, is it a good idea to protect the control boards with surge volt suppressors?
Never hurts. I mean, good idea, sure. Do I see people do it very often? No. Just because that scenario where they saved you is so rare that the extra cost is just kind of, most people want to put it in their pocket.
I/O builds some of that suppression a little bit into our power circuit. But if the house got hit by lightning, then nothing's going to save it. So again, it would be a great idea if you're doing it and it's part of your offering. I mean, some contractors put surge protection on every single job they do. That's awesome. But there's really no need. If the house got hit by lightning, you're going to turn it in. The homeowner's going to turn it in under their homeowner's insurance and get it replaced anyway.
Yeah, I should note that I guess all of the I/O boards have a 10-year warranty. So in general, if someone's board gets zapped after 10 years, I hope that they feel like they got their money's worth. and if it gets zapped before, it's under warranty. So
Okay. Next question is from Frank. He's asking about the outdoor sensors, and is it required or is it not required with Wi-Fi stats? I mean, you shouldn't have to use that, correct?
it's not required, but again, I guess the only thing I would really have to caution you towards is making sure that every Wi-Fi thermostat is configured identically to its other two zones or however many you have.
Well, I heard that question a little bit differently. If the thermostat had a wireless outdoor sensor, that still doesn't help us because there's no way to transmit that data down to the panel. The panel's technically not communicating.
To repeat the question.
Yeah.
The question was, if you're using Wi-Fi thermostats, do you no longer have to use an outdoor sensor because the Wi-Fi stat's pulling the outdoor temperature from
I misunderstood.
From the web. So the answer is, you could avoid it by doing that, but you would really have to make sure that you've configured all of your Wi-Fi stats identically so that their logic is exactly one another. Because the problem is that if one thermostat thinks that it's below balance point and another one doesn't, that disagreement can cause, it might not cause any real issues, but if you were to ever have to go back to the job and troubleshoot it, it would just be unbelievably confusing.
Yeah. It's always best to let the panel do the balance point
Right.
work for you, whether it's IO or Honeywell, anybody's.
Yeah.
You always want, since it's going to really be controlling the balance point, it's the device that really needs to get the outdoor temperature.
Next question is from Tyler. He asked, do you ever think it's okay for a tech to try to fix the board via soldering iron and that technical skill?
If they feel comfortable doing so, more power to them.
Yeah.
The one thing I will say that if we think that the board was damaged because someone was burning it with a soldering iron, the warranty may be void.
Yeah.
But if you can see a component was damaged and you want to replace it and you feel really confident that you can do that and that was the problem, more power to you again.
Yeah. Most people would just, if there was something wrong, they would just send it back, let us get you a new panel. That way you're much more confident and you don't have to worry about a return call to come back because it didn't get soldered correctly. So while you could, for sure, if you looked at the back of the panel, it's not an iPhone with a billion components on it. It's pretty straightforward. It's all, this one happens to be all through-hole boards, so it's not surface mount. So it technically, you could, and I know Ty and Ron and all the team, I mean, you'll see them in the lab actually soldering on them for sure. So you could, but it's best just to let us replace it.
And just to note, like the ESP panels, and I would be surprised if Honeywell wasn't the same way, but the stuff's going towards surface mount rapidly. That kind of stuff is so difficult to solder with accuracy and precision.
Yeah.
It's just, I would say, even if someone who feels really comfortable soldering, I wouldn't bother.
Yeah.
I would just return it for warranty and get a replacement.
Okay. All right, Dwayne, he really wants to know your opinion. Which is better, IO, Train, or Honeywell zoning system?
Well, I'll start.
Repeat the question.
Yeah, Dwayne wanted to know which he considered the best zoning system, whether Train, IO, or Honeywell. And first I'll say with Train or Carrier, someone asked about water furnace earlier on the online chat. A lot of those equipment manufacturers do make their own proprietary zoning. I actually happen to have a Carrier Infinity in my house. I'm sorry if I offend anyone that's a Train dealer out there. I used to work for the Train distributor, so I love Train, but my contractor I use, because I have no mechanical ability, like Carrier, so that's fine. So I have Infinity in my house. I don't even have an I/O panel. But if you've got the high-end equipment that is communicating, we always recommend that you use that equipment manufacturer's zone panel. We make dampers, or I/O makes dampers for Train and Carrier, and Lennox and York and all those. So we've got great dampers that'll work with it, but the panel itself, I highly recommend using the manufacturer's zone panel because it's communicating, and the big thing is the zone panel can talk directly to the equipment.
Right.
And that way, even though we've come a long way with the ESP, does a lot of the really cool things. The thing that Trane or Carrier has over what IO can do, and Honeywell cannot do it either, is they can actually directly control the variable speed fan. So in that case, if it's high-end equipment that's communicating, I would always tell you to buy that manufacturer's zoning. Honeywell, obviously, we sell a lot of Honeywell. They make great stuff. If you're doing some of the wireless things, wireless thermostats, all that, Honeywell's a great solution. If you're looking for the simplest, easiest to install, the most competitively priced, then IO is the solution. So it really depends on where you're at, in my opinion. All three are a great solution, and and if you've got questions on that, feel free to call, and we'd love to walk you through it.
Yeah, I would agree. Obviously, the Trane proprietary stuff, the stuff that's getting communicated down that proprietary communication is information that you just can't send down standard thermostat wires, so it just makes it, the level of control is just wild there. As far as Honeywell, I think that the wireless zoning adapter is absolutely awesome. But beyond that, I would say that's really the only feature that Honeywell's is just like really, really special. IO stuff, especially with the ESP, the value there is just so huge. You're spending either way less money or you're spending close to as much money, but you don't have to install the bypass damper because of ESP. You know, Honeywell doesn't have anything like ESP, which makes IO's ESP panels really really competitive.
The other interesting thing I'll add is Goodman has got a product out that they call Comfort Bridge that they're installing in all of their higher end equipment, which is, they've done something unique, and to their credit, I think they understood that there's this huge, there's so many homeowners that say they want a Nest thermostat in their house now. No matter what, they don't care about the equipment. They just want a Nest thermostat. It's cool. They've been sold on the Nest or Ecobee. There's some really cool thermostats out there. But whether it's Nest or Ecobee or whoever, at the end of the day, ooh, love that phrase, at the end of the day, they're just conventional thermostats. They're neat Wi-Fi, and they may sense your presence and can tell you to, you can talk to it, and it's got Amazon Alexa built into it or whatever the case may be. But it's still just a regular thermostat that, you're making a set of contacts across R and Y to bring on the cooling. So Goodman's decided, well, we're not going to try to change the homeowner's belief that they need a Nest thermostat. So they put all the smarts built directly into the air handler or the gas furnace, and all of that is done internally, so you can still use a regular single-stage thermostat, but have their most complicated variable speed, communicating, the indoor and outdoor units can talk to one another and all those things, but the interface for the homeowner is just that regular thermostat. So that's kind of something neat. We're excited about it as somebody that's a wholesaler for third-party products, because we don't have a line of equipment or anything. That's really neat. So the IO zoning, the Honeywell zoning, all the traditional zoning will be able to work with their high-end equipment. So that's something else to keep in mind. I think you're going to see more and more equipment manufacturers going to that because the homeowners are demanding they want that cool thermostat, or maybe they want a Crestron thermostat because they've got this sophisticated home automation system in their house or whatever. So we've rambled on.
Here's an interesting question from Christopher. He asked, do you custom imprint on zone panels?
Yes, we can.
So the question was, do we custom imprint on zone panels?
We can. If you're interested in that, if we'd love to just follow up with you, you can shoot us an email or whatever, and we'll follow up with you. We do have a couple of different options we can do to private, quote unquote, private label the panels, and we just have to review those with you. We've done stickers, we've done the 3D
Decals.
like the IO one here. So we've got some different options. We just need to review what exactly you're looking for. Obviously, we'll imprint your thermostats for free with your company information on it. But the panels are a little bit different scenario because they don't fit into the printing machine that we have. So we'll just have to review that with you. But the answer is yes, we can private label the zoning for you as well.
All right. Then our final question was just going real quickly back to the ESP. So how do you, again, adjust the static pressure?
Oh, there's one right up there.
So
Is it?
the question is, how do you adjust the static pressure on an ESP panel? So each ESP panel, if it has ESP in the part number, it ships with one of these. So you would just mount this on the ductwork most of the time. You would put this in the supply ductwork.
And it comes with the probe and the
Yep,
tube,
it
right?
comes with all the poly tube and the probe, and that just slides right off. And this is the dial where you say, hey, what static pressure is too high, basically. We ship it at 0.35 inches of water column, and you can adjust it to your heart's desire.
Yeah, the nice thing is it's fully calibrated too. So when you get it from us, if you set it at 0.35, it's going to be right on 0.35, so you don't have to get out any test equipment. Just set it. And the cool thing is you can set it on the fly too. You can actually sit there and adjust it and watch it work.
Yeah,
so,
if it's right next, if it's close to the ESP panel, you can crank that thing all the way down, and you'll see the ESP LED on the panel light up and say, hey, the static's too high now.
Yeah.
All right. Last thing, Tom, if you advance to the next slide, we can talk about our promo we have going on.
Oh, look at that beautiful promo. So we've got 10% off zoning products, dampers, are the standard zone panels, ESP zone panels. There is a promo code of 20 zone 10T. Again, 20 zone 10T when ordering. That's good through June 12th. And if you're looking to place an order, feel free to give us a call or shoot us an email and reference that promo code, and you'll get 10% off your next zoning order. That's pretty cool.
Yep.
Who approved that, by the way? Who's in charge of that? Okay, marketing. All right, we'll have to get with them later. No, but please, we'd love the opportunity to earn your zoning business. And is that it?
That's it.
That's it. Well, hey, everyone, have a great night. Just a little special shout out since it's Memorial Day to remember all of those who have fought valiantly to give us our freedom. So have a safe, wonderful holiday weekend. And Ty?
Yeah, have a great weekend, and hopefully a long weekend for you. Thanks for tuning in.